In rural India, it's a common sight that water is stored in earthen pots. A sip from it, and you will realize that the water is cold. How is it that earthen pots can cool water without use of any electricity? Before we get into solving the mystery of cooling pot, let us try and understand what is hot and cold. Molecules in matter possess kinetic energy, hence because of which they are in state of perpetual motion. But along with that, there are forces acting on the molecules. Hence, they possess certain amount of potential energy as well as they do work against these forces. What would happen if when we provide heat to these molecules? Heat can bring about two changes. It can increase the kinetic energy of the molecule. Meanwhile, heat could also do work against the forces causing change in potential energy. The sum of the total kinetic energy and the potential energy of a system of particles is known as its internal energy. And as we saw, heating can change both the kinetic and potential energy of the system. We can assume and say heat is associated with the internal energy of the system. That is, providing heat can change the internal energy of the system. On the other hand, temperature, which we generally associate with the degree of cold or warm a body has, is associated with the average kinetic energy of the system. Hence, increasing the kinetic energy of the system results in increasing the temperature. As temperature is associated with the average kinetic energy of the system, at any given temperature, some of the molecules will possess higher kinetic energy while others will possess lower kinetic energy. If one of such molecules having sufficiently high kinetic energy is present near the surface of the fluid, it may manage to overcome the forces of attraction and escape into the atmosphere. This process is known as evaporation. As molecules having higher kinetic energy escape into the atmosphere, most of the molecules left behind in the liquid have lower kinetic energy. Hence, the average kinetic energy of the liquid falls. As temperature is proportional to the average kinetic energy, temperature of the liquid falls, resulting into cooling. Evaporation can take place at any temperature below the boiling point. If the surface area of the fluid present is larger, it would result into greater chances of the molecules escaping into the atmosphere. Hence, the rate of evaporation increases with increase in exposed surface area of the fluid. Increasing the temperature of the system will result in more number of molecules having higher kinetic energy, and hence greater number of molecules escape into the atmosphere. Increasing the temperature increases the rate of evaporation. If the space about the surface of the liquid is already saturated with many molecules of the liquid, evaporation is hampered. Hence, increased humidity level causes reduction in the rate of evaporation. Wind can carry away the already existing molecules of the fluid from the atmosphere, hence providing space for new molecules to evaporate. Therefore, wind increases the rate of evaporation. Wait now, what was the question we were trying to answer?